Good morning, everyone. We are going to continue with the unit number 4, that is IoT protocols and security. So, in the last session, we have discussed about the protocol standardization for IoT efforts. In that, we have seen the World Package Framework, and also we have covered the M2M or that IoT, what we can say that Internet Protocol for Smart Objects, and we have covered the M2M and WSN protocols. Okay, and we have seen the activities for M2M and WSN protocol standardization. That is your standardization activities. Similarly, we have discussed about the SCADA and RFID protocols, and we have discussed about the activities for RFID and SCADA, and also we have discussed the issues with the IoT standardization. Okay, now in today's session, we are going to start with the unified data standards. Okay, the standards in IoT for data exchange. Previously, for the data exchange, that internet uses the HTTP protocol, okay, or it uses the HTML and HTTP for representing the data over the internet. Nowadays, more protocols uses XML-based file representation, which makes a data exchange easier for the different techniques. So it is helpful to use that XML-based representation. Okay, so it is this XML representation for data exchange or data transfer. Okay, then RDF. RDF means resource description framework. So that resource description framework, it is a work of W3C, and it was originally developed for a metadata model. Okay, so RDF can be used for modeling of information, that is deployed as a web resource. Okay, RDF, it can be used for modeling the information, that information is deployed as a web resource. It also uses a REST API. Okay, it also uses the REST API. We have seen what are the REST APIs, and now here you can see the word EBXML. Okay, here EBXML means in the very first unit we have discussed about the SOAP, that is SOAP and REST frameworks that can be used to provide data exchange protocols for IoT applications. Okay, so we have discussed about the electronic data exchange or interchange, that is EDI, electronic data interchange. It is a technology that describes the format of electronic documents. That documents can be shared over the internet. That is EDI. And that EDI defines some techniques for FTP and email SMTP. Okay, that is electronic data interchange. This technique is for FTP, email, HTTP, and SMTP. So the combination of two famous techniques, that is EDI and XML, that is extensible markup language and electronic data exchange or interchange. So the combination of these two, that is EBXML, that gives or it arises a new technique that is called as EBXML. Okay, so this EBXML can be used for, or it is mostly used for e-commerce solutions. E-commerce software communication uses EBXML. Okay, this is a standard which specifies rules of interaction between two parties. Okay, so there are different formats that are accepted by the WOT, that are like for EXDL, that is Emergency Data Exchange Language of OASIS. So these are the different techniques are there for this standard. Okay, so EBXML can be used for e-commerce solutions. Then next one is your different protocols for IoT protocols. So there are different protocols are there, like IEEE 802.15.4. Then BacNet is there, ModBus is there, KNX is there, and Zigbee is there. So these are the different IoT protocols are there. Okay, so now we are going to see one by one. First we will see IEEE 802.15.4. So here this IEEE means your Institute of Electrical and Electronic Engineers. So this group define the 802 standards. Okay, so from that we are going to discuss about the 802.15.4 protocol. Okay, so here that different wireless protocols or wireless communication standards are there for that. like it includes the IEEE 802.11, then Bluetooth is there, GSM. Okay, so these are the different communication standards are there. In that we are going to discuss about the some new protocols like 802.15.4 and Zigbee. Okay, so first we will discuss about the 802.15.4. See the working group of 802.15. So this IEEE 802 family about that LAN and MAN standards committee is there. So it includes the 802.1, 802.11, 802.15 and 802.17. Among that, we are going to discuss about the 802.15, that is wireless personal area network, that is WPAN. Okay, WPAN we are going to discuss. So here you can see that there are different task groups are there, like there are 4 task groups are there, that is WPAN or Bluetooth is there. Then coexistence task group is there, then WPAN high rate and WPAN low rate task group is there. Okay, we are going to discuss about this low rate task group. Okay, so this IEEE 802.15.4 is a wireless communication standard, and we are going to discuss about this wireless personal area network working group. Okay, so this task group begin to develop a standard for low rate wireless personal area network, that is LRWPAN. Okay, so the goal of this group was to provide a standard with ultra low complexity or cost and power for low data rate wireless connectivity. Okay, that are fixed, portable, and moving devices are there. Okay, the standard is for with the ultra low complexity devices. Okay, then see the property and the range for these devices, like raw data rate is there, range is from 10 to 20 meter is there, latency is there down to 15 ms. Okay, so different channels are there. Here you can see the 11 channels are there. Okay, then a frequency band, two physical layer here. Okay, there are two physical layers are there. We are going to frequency bands are there. We are going to discuss about that. Okay, addressing is like 8-bit address or 64-bit address is there, and channels like CSMA or slotted CSMA. Okay, these are the access channels are there for this IEEE 802.15.4 protocol. Okay, so now there are different approaches are there for the low power, as we are going to discuss about the LRWPAN, that is low rate or low power. Okay, so there are different approaches are there for this to achieve the low power and the low cost goals for this protocol. So first approach is here, reduce the amount of data transmitted. We have to reduce the amount of data to be transmitted. Okay, that means we have to send the low amount of data. Okay, then we have to reduce the receiver's duty cycle and frequency of data transmissions. In that what we can say, in the frame format, we are going to discuss about this discuss about the uh, frequency of frame format. Okay, so we have to reduce the frame overhead. We are going to cover this point in the frame format of that IEEE 802.15.4. Okay, so we have to reduce the complexity, we have to reduce the range. Okay, we have to implement a strict power management mechanism for this protocol. These are the several approaches for this protocol. Okay, then this IEEE protocol deals with only physical layer. Okay, as we know that there are 7 layers are there for the OSI model. So this protocol only deals with the physical layer and some portion of data link layer. Some portion of data link layer means it's going to be deal with the MAC layer and the LLC layer, that is logical link control layer. Okay, so these higher layer protocols are left to industry and the individual application. So this protocol only deals with the physical layer and the portion of this data link layer. Okay, then here you can see that IEEE 802.15.4. So this will deals with only the physical layer with the different frequencies and some portion of the data link layer. Some portion of the data link layer means that portion includes the LLC and the MAC. Okay, that is MAC addressing here. You can see that logical link control and media access control. Okay, so it only deals with the MAC and LLC of the data link layer. Here you can see that that IEEE 802.4 802.15.4. The standard supports multiple network topology that includes star and peer-to-peer topology. Here you can see that star and a peer-to-peer network for this protocol. Here you can see the PAN coordinator is there, and personal area network. This coordinator is there. That red circle indicates that PAN coordinator, and here you can see these different devices are there. This is the star network, and this is the peer-to-peer network. You know that what is star network and peer-to-peer network. Okay, so this protocol uses this star and peer-to-peer network. Okay, then as we have seen that that uh, it works only, or this protocol deals with only physical layer and some portion of the data link layer. That portion of that data link layer, that means it splits the data link layer into two sublayers, that is MAC and LLC. These are the two sublayers from this data link layer. Okay, so this LLC, that is logical link control. Okay, so it is a standardized and it is a common. It is common in this 802.3, 802.11, and 802.15.1. This is the family of 802.802, family of IEEE 802. Okay, and LLC is a common in this all the protocol. Okay, so these are the features of the features of this protocol for the MAC. Features are like, here you can see association and disassociation is there. Acknowledged frame delivery, where first frame is acknowledged by the receiver. Okay, so then channel access mechanisms is there. Frame validation, guaranteed time slot management. Guaranteed time slot is for the transmission of the frames. So here that MAC provides this media access control layer. It provides the data and management services for the upper layers. So this 802.15.4 describes MAC in two parts. One MAC layer responsible for data transfer, and is also known as MAC common part sublayer, that is MCPS, MAC common part sublayer. And second part is responsible for MAC layer management, and it is also known as MAC layer management entity, that is MLME. So these are the configurations for the MAC. Okay, so this is all about the IEEE 802.15.4 MAC. Okay, so this MAC is the part of your data link layer. See, now we are going to discuss about the frame format. Frame format for the IEEE 802.15.4. This is the frame format for this protocol. So this frame includes the see the 2 bytes of frame control. 1 byte is for the sequence number. Then this is for the address field. Address field is up to 20 bytes. Okay. Then payload, that is data payload is there. Then FCS, that is frame check sequence, is of 2 bytes. Then see this is the MAC sublayer. It includes the MAC header. Then MSDU, that is MAC service data unit, and MAC footer is there. Then MAC protocol data unit is there. See this at the physical layer, it's having the physical protocol data unit and physical service data unit. Okay, yeah, physical service data unit, and having the physical header, that is of 1 byte, and synchronization header is up to 5 bytes. Okay, so this is the frame format for the IEEE 802.15.4. So this MAC layer frame decides this MAC layer just above this physical layer. Okay, so here that PSDU, that is physical service data unit, it can be, or it is in between the 0 to 127 bytes in size. Okay, and that synchronization header is of 5 bytes, and that physical header is of 1 byte in size. Okay, so here this frame control field, this field indicates the type of MAC frame that is being to be transmitted, or it specifies the format of the address field. Here you can see this address field is there. What that frame control describes, it is a field that indicates the type of MAC frame. Okay, then multiple address types are there. Like we have seen that 64-bit physical address is there, and a short 8-bit network is assigned, or that address is of like 8 bits in size. Okay, then address field size. See this address field size, or this address information. It may vary from 0 to 20 bytes, 0 to 20 bytes, or that MAC frame. See this payload field. this payload field or data to be transmitted here, data payload. Okay, this payload field is variable with condition size of that MAC frame, or it is less than or equals to 127 bytes. Okay, in size. Or FCS, that FCS means your frame check sequence. It is of 2 bytes. Okay, and it is used for integrity check using this CRC. Okay, we are going to calculate the CRC using the CRC method. Okay, that is of top, or it uses the 16 bits for the CRC. Okay, then as we have seen that the standard provides two physical options with the frequency bands, as that two frequency bands is one is from like 2.4 gigahertz band. It has worldwide availability and provides a transmission rate of 250 kbps. Okay, this is the one band. And then next one is your the 868 or 915 megahertz physical. This band specifies the operation in the 868 megahertz band. Okay, so these are the two different bands are there for this protocol. Okay, so this is this channel structure for this protocol. It is not the part for this frame format. Okay, then these are the frequency modulations are there. Different frequency bands are available for this. Like here you can see these frequency bands for 868 or 915. Or these are the data parameters are there and spreading parameters are there. Okay, this chart is for the modulation purpose. Okay, whenever you are going to set up this protocol for any particular system, at that time it will be helpful. Okay, so different practical, yeah, as I said, the different practical setups are there for this IEEE 802.15.4. At that time, this range or all these parts like parameters or what we can say, this modulation techniques are used. Different range is there. This part is useful for the setup of this protocol. Okay, this is all about the IEEE 802.15.4. So use of this protocol is like with the limited operating power or low power requirements. That low power requirements make it highly scalable. Okay, because of this low power requirement, or the network maintenance is low cost and it is reliable. Okay, so this is all about the IEEE 802.15.4 protocol. And next protocol is your ModBus. Okay, so this ModBus is a serial communication protocol. Serial communication protocol, and it is developed by the Modicon Incorporation. Okay, so this ModBus is a serial communication protocol, and it is used to establish a master slave connection. Or here, this Modbus is an application layer protocol. Application layer protocol. That means this protocol is used at the application layer, so which provides client server communication. Okay, so this protocol is a serial communication protocol, and it is an application layer protocol which provides client server communication to the devices. The devices are connected via buses and network. Okay, so it is used to establish client server communication or master slave communication between the intelligent devices. Okay, so this Modbus also works on the top of serial communication standards like RS-232, RS-442, or RS-485. These are the different standards for the serial communication. Okay, on that Modbus is going to be work. Then this Modbus works with master slave model. Okay, this Modbus enables communication between many, or what we can say, approximately 247 devices that are connected to the same network. Okay, this Modbus works with the master slave model. Then it only here you can see that different devices communicate using the master slave technique, in which only one device, or the only one device means the master, only master can initiate the transactions, or it will be called for the queries to the slave. Okay, only master can initiate the transaction, and the other devices means slaves. Slave is going to be respond by supplying the requested data to the master. Master is going to be request or going to send the request to initialize the transaction to the slaves, and slave is going to respond to the master for the transactions. Okay, so yeah, the slave devices works according to the query or the return data generated as a result of query to the query from the master. Okay, so that means master slave communication is there, or that the slave is any peripheral device. Slave can be any peripheral device like IO transducer is there, network, or any other measuring device is there. So which processes information and send its output to the master. Okay, so master can address individual slave, or it can initiate a broadcast message to all the slaves. Okay, that means one-to-one communication is there, and also one-to-all. That means broadcast message to all the slaves. Okay, so that Modbus has two transmission modes. Two transmission modes that defines framing and bit encoding for messages to be transmitted on the network. These are the two transmission modes. Okay, like ASCII or ASCII transmission mode, that is American Standard Code for Information Interchange, that is ASCII transmission mode, and remote terminal unit, that is RTU transmission mode. Okay, so here you can see the basic Modbus network. So here you can see one master is there. Master is going to send the request to the slave, and the slave is going to perform some operation based on the request and going to send the reply to the master. That means this is going to be communicate with each other. That means master slave communication is there. Then here see the Modbus transaction. We are having the master and slave. So master is going to initiate the request with their function code or with their data request, whatever it is. Okay, so master is going to initiate the request, and this request is sent to the slave. So slave is going to perform the action based on this request or initiate the response, and this response is going to be, or the slave will send this response to the master, and master is going to receive the response from this slave based on this master's request. Okay, so this is the communication between the master and slave. Okay, so that now see the Modbus frames. So it's having the ADU and the PDU, that is application data unit and protocol data unit. They are the two frames. Okay, so this PDU frames, sorry, so the PDU frames, it includes the function code and the data, and this ADU frames includes the function code, data, or the error check. Okay, so this function code action, it is action to perform, and the data, that data is information to be used for this action. Okay, that is the function code includes the data and the operation or actions to perform on this data. Okay, see the Modbus data types. So Modbus transaction is always perform a set of actions by reading or writing to a set of 4 data, or it is used by the Modbus application layer. So see this discrete input is there, coils, input registers, holding registers. See the object type and their type. Like you can only is there, read write operation is there, read only, read write. Okay, these are the data types for this Modbus. Okay, so the function of this Modbus protocol is like it defines the action to be taken by the message. Then Modbus function field contains 2 characters in ASCII mode and 8 bits in RTU. That RTU is your, this is the transmission mode, as we have seen that RTU transmission mode here. Where it is RTU transmission mode. That means these are the what we can say transmission mode for the Modbus. We have seen that Modbus has 2 transmission modes for the framing and bit encoding of the messages. Okay, that is your remote terminal unit transmission. Okay, then Modbus accessing data. How Modbus is going to access the data? Okay, so before that, Modbus addresses. So that addresses begins with 8-bit address of target that ranges from decimal value up to 1 to 247. Okay, or in that 0 is used for specifying broadcast address. Okay, and each query has the address of specific slave that is defined in the frame format of the both modes, that is modes like your ASCII and RTU mode. Okay, so that address field contains 2 characters in the ASCII mode and 8 bits in the RTU code. So that Modbus accessing data, that 16-bit unsigned registers and single bit coils. Here you can see that single bit coils. Coils is your single bit coils is there. Okay, so 16-bit unsigned registers and single bit coils. That means input registers and holding registers, input coils and your status coils, and that 64 KB of space is allocated for registers and coils. See that 64 KB space. That this space is allocated for the register and the coils in the Modbus for accessing the data. Okay. Then see the transmission mode. We have discussed about the transmission modes, having two transmission modes. Like one is ASCII and another one is your RTU. Okay. So this ASCII, it uses longitude redundancy check, that is LREC. Okay. And this remote terminal unit uses CRC, that is cyclic redundancy check. Okay, these two techniques for this two transmission mode. So in the in Modbus RTU, okay, that bytes are sent consecutively with 3 to 1/2 character space between messages for a delimiter. So this will allow a software to know when new message is starting. So that is your frame format, that when that message is going to be started. Okay, so that is the space between the character, okay, or the space between the messages. Okay, then any delay between bytes will cause Modbus RTU to interpret it as the start of a new message. If that message, or if is there any delay between these bytes, or for a single message, after sending the single message, is there any delay between that bytes, that means it will consider that, or RTU is going to be interpret that it is the start of a new message. Okay, then Modbus ASCII marks the start of each message with a colon character. Here you can see this colon character, that means this is the hex 3A, and the end of each message is terminated with the carry. Okay, so this start of the each message with the colon, and end of each message is terminated with the carriage, that is return and line feed characters. Okay, that is from the hex 0D and 0A. Okay, see the ASCII mode. ASCII mode for the different characters, or this is the coding system. Okay, when controllers are set up to communicate on a Modbus network using ASCII. ASCII means your American standard code. Different codes are different for every character, every number. We are having the coding system. Okay, in the ASCII mode. So each 8-bit byte in a message is sent as 2 ASCII characters. Okay, so the main advantage of this mode is that it allows time intervals of up to 1 second to occur between the characters without causing an error. Okay, see the format of each byte in ASCII code. So this coding system, hexadecimal ASCII characters 0 to 9. Okay, and A to F. You know that ASCII characters from 0 to 9 and A to F. Okay, one hexadecimal character contained in each ASCII character of the message. So bits per byte, one start bit. Okay, one start bit for each ASCII character. One start bit is there, 8 or at least 7 data bits. Okay, least significant bit sent first. That means your 8 bits or 8 data bit. That is LSB sent first. First it will send the LSB bit. Okay, then 1 bit for even or odd parity. That means no bit for the no parity. Okay, if there is parity, even or odd, then 1 bit for that, and 1 stop bit if parity is used, then 2 bits if no parity. Okay, so then error check field. Okay, or CRC is used for the error checking. Okay, that is you can also use the LRC or CRC for this error checking. Okay, so this is all about the transmission mode, ASCII mode. Okay, similarly another mode is your RTU mode. Okay, so in the RTU mode, this coding system includes 2 hexadecimal characters. Okay, that are contained in each 8-bit field of message. Okay, so this 8-bit binary with 2 hexadecimal characters. It is from 0 to 9 and A to F. Okay, here you can see this. This is similar for this what we can say, this RTU mode. Okay, their only difference is like 8 data bits for the list LSB bit. Okay, and here you can see for the ASCII mode 7 data bits are there for this, and here LSB bits sent first, and for the RTU 8 data bits are there and LSB bits sent first. Okay, so only difference is that for between these two modes. Okay, these are the format for this coding system of this RTU mode and the ASCII mode. Okay, so till now we have discussed about the unified data standard and the protocol. We have discussed the IEEE 802.15.4 protocol, and we have discussed about the ModBus protocol. In the next section we are going to discuss about the BacNet. Okay, and we are going to discuss about the KNX and the Zigbee. Okay, so today in today's session we have discussed about the protocols and the unified data standards. We are going to stop here. Okay, thank you.